so strange is because it's literally taking 3 different pieces of 3 different functions and kind of plotting them all in one number line. And they end up looking really weird, and it's kind of a complicated thing to wrap your head around. So what I want you guys to do, we're gonna try to keep this super organized and super segmented. This first one right here, the function x plus 2, if x is less than or equal to -2, I want you to label that a. So we're gonna have 3 different functions in 3 different pieces. Okay, so that one's a. The next piece of the piecewise function, we're gonna label this b, and then the last one will be c. Okay, and I'm gonna color code. I don't know how well you guys are gonna see the color coding. That way we can kind of keep all of them separate. So if I just gave you f of x equals x plus 2, I think you guys would be able to graph that no problem. You'd be able to make a table of x values, plug them in, get a bunch of y values, and plot your ordered pairs and be done with it. The tricky thing with this is you're not allowed to plug in just any x value you want. You're only allowed to plug in x values that are less than or equal to -2. And then the same thing happens with this next one and with this next one. It would probably be no issue whatsoever to set up a table and plug in some different x values. The issue is, for this middle one, you're only allowed to plug in x values that are between -2 and 0. And for this last one, you're only allowed to plug in x values that are greater than or equal to 0. So I want you guys to start off right away, and this is a little bit different than I did in the notes. I want you to start off right away by turning your x-axis into different segments. So we're gonna start just by setting up a coordinate system and kind of separating it out into different intervals. Okay, so if we look right here, start with x is less than or equal to -2. So what I want you to do is find that endpoint, that -2. So go 2 units on your x-axis. And what we're gonna do is literally divide our x-axis. So take this and turn it into a dotted line, and it's gonna divide our coordinate system into 2 different pieces. Okay, so when we say x is less than or equal to -2, that's just gonna be this part over here. So we use -2 as a dividing line, and less than would be over to the left. So just this segment over here is gonna go with part A. Okay, so graph A is gonna be graphed just in this interval over here. We're not allowed to graph it over here at all, because we're only allowed to graph it for x values that are less than or equal to -2. Okay, then move on to the next piece. The next piece, the function is 3, and we're only allowed to graph it between -2 and 0. Okay, so we already have a dividing line at -2. Now I want you to draw in a dividing line at 0, and I know it's right on the y-axis, so it'll kind of blend in. And now we're gonna label that. So B is only gonna be in this little segment right here. That's the only place that we're gonna graph B. Will be right in this little strip. And it matches with these values right here. And then the last one is just gonna be x is greater than or equal to 0. So here's 0, and we're only gonna plot it over on the right-hand side. So label this last part C. Okay, so graph A is only gonna be plotted in this interval. Graph B is only gonna be plotted in this little sliver right here, and graph C will be over on the right. Okay, Kat, question?
I figured it out.
Okay. All right, so that's kind of splitting up. So that's the first thing that I want you guys to do. And like I said, this is slightly different than what I did in the notes. So just looking at these x values and segmenting into 3 different sections in the coordinate system. Okay, so any questions on how I used these inequalities to segment off my graph? No? Okay. All right, so let's start to look at the different functions. So function A, label this right here. Function A is the function f of x equals x plus 2. Okay, so like I said before, if I just told you to graph that, I think you guys would have no problem with that. You'd pick a bunch of different x values, plug them in, plot a bunch of different ordered pairs. The thing that makes it tricky is you're not allowed to graph it anywhere you want. You're only allowed to graph it over here. Okay, so the first thing I want you guys to do is always plug in that endpoint. Okay, so that endpoint is -2, so I want you to start by plugging in the -2. Okay, so with this notation, remember that means from chapter 1, you're taking the function and plugging in a -2. So replace the x with the -2, like that. So I just took this function right here and I just replaced the x with the -2. So that leaves me with 0. Okay, so I plug in an x value, I get out a y value, so that means that the ordered pair that I'm going to plot is -2, 0. Okay, so you always, always plug in the endpoint for sure. And the endpoint is what's listed right here. Okay, then pick something else, because I'm allowed to plot anything else I want as long as it's less than or equal to -2. So give me another value I can plug in. -3, good. -3 would also fall into that category. So I can go ahead and plug in the -3. Or you could have chosen -4 or -5 or -6, any other number as long as it falls in this category. Okay, so if we plug in -3, I'm going back into this function right here, but I'm replacing the x with a -3 this time. Okay, so that leaves me with a -1. So that means I plug in an x, I get out a y. This is my next ordered pair. Okay, so we're gonna plot those 2 ordered pairs, because you know with lines, all you really need is 2 ordered pairs in order to actually plot it. Okay, so one very important thing while I'm plotting, if you plot anything on these lines, you have to pay attention to whether it would be an open or closed circle. So when I actually plot something at -2, pay attention to this inequality symbol. So based on this inequality symbol, would I put an open circle or a closed circle? It would be closed. Good. What makes it closed? The or equal to. Good. When you have the or equal to, just like a normal number line, when you guys are plotting things on number lines, the or equal to makes it closed. So when I plot the -2, you have to make sure it's a closed circle. So -2, 0 would be a closed circle right here. Okay, and then I can also plot this point. So I can also add onto my graph the point -3, -1, which should be right here. And anything that's within the interval is just a normal point. It's only when it's on the edges of the interval that you have to worry about whether it's open or closed. Okay, so remember, my green letter A is only being plotted in this part of the graph right here. You can't go past this dotted line. So it starts here and then it just extends off to the left. Okay, so it's just a little piece of a line. It's not the whole line, it's just part of it. Okay, so this ends up being a ray. You know how a ray is closed on one side and then it has an arrow on the other. So on your left part of the graph, you'll always have a ray. Okay, so let's go piece by piece. Any questions on this one? Okay, next piece. Letter B. This function is f of x equals 3. So this means no matter what you plug in, the function value is going to be 3 because there's no x in there. So this statement right here just says the function value is always 3. Doesn't matter what you plug in for x, you're going to get 3 as your function value. Okay, so this one's a little bit different than the first one because this one will end up being a segment. It's closed off on both sides. So you definitely want to plug in both of these endpoints. So whatever you have for your middle function, plug in both of the endpoints and see what those will give you. Okay, so we're going to plug in -2 because that's where my interval starts, and then you're also going to plug in 0, that's where your interval ends. So whatever these 2 values are for the middle piece, you're always going to plug both of those in. Okay, so like I said, here's the beauty of this just being a number. No matter what you plug in, you're going to get 3. So if I plug in -2, I get 3. If I plug in 0, I get 3. The fact that that's just a number means that's the number I get no matter what I plug in. So this first coordinate point would be -2, 3, and then the next coordinate point would be 0, 3. Okay, so plot both of those, but pay attention and be careful. Look at these endpoints. So when I plot the -2, would the -2 be an open or closed circle? Open. Good. So I'm going to plot this point, but it's going to be open. Because up here in the interval, it just has a less than attached to the -2. It doesn't have a less than or equal to. So I'm going to plot -2, 3, which will be right here, and I'm going to plot it with an open circle. Okay, then go to the next one. The next point is 0, 3. 0 is my other endpoint. So look back up at this interval. At 0, would I have an open or closed circle? Open. Good. So 0, 3 will also be an open circle, and that will be right here. And then with the segment in this middle section here, you just connect the dots. Okay, so the middle will always be a segment. because it ends on these lines. You can't go outside of this little interval that I sketched in. So since you can't go past this line or this line, it'll just be a segment in between. Okay, so again, piece by piece. Any questions on this little section B? And this little line that we have right here. Okay, let's move on to the last one. Last one is segment C. And this function this time is 3x. Okay, so for the pieces, the piece at the beginning and the piece at the end, you always plug in the endpoint that you see right here, and then you just get to pick whichever else you want to plug in. Okay, so for the first and last, always use the endpoint, and then just pick whatever else you want to plug in. In the middle, you have to use the 2 endpoints that were given to you. Okay, so this one we start by plugging in the 0. So we're going to do f of 0, and that will just get plugged in for the x right here. So 3 times 0, which is 0. So that ordered pair just goes right through the origin. This is just 0, 0. And then pick anything else you want in this interval. 1. Okay, so good. 1 would definitely be in that interval. So we plug 1 in. So we have 3 times 1, which is 3. And so that means I'm also going to plot the ordered pair 1, 3. Okay, so each one of these, for interval A and B and C, you have to have 2 ordered pairs. You have to have at least 2, otherwise you're not going to see the shape of the line. Okay, so start with 0, 0. But before I plot that point, because remember that's my endpoint, before I plot my endpoint, you need to know if it's open or closed. And what would it be here? Closed, good, because I have the or equal to. So start with a closed circle right here. And then plot the next point. So 1, 3, remember when you're in the interval, like if you're somewhere inside the interval, you're always closed. It's just when you're right on the edges of the interval that you have to pay attention to whether it's open or closed. So when we plot 1, 3, it's just a normal point. So just put a little dot right there and then connect the dots. And then you've got array. So we have array on the left, array on the right, and a segment in the middle, always. Okay, so that would be your piecewise function. It's very strange. It's like you kind of cut and pasted different pieces of different functions and put them on the same coordinate plane. Okay, so last thing we have to talk about is domain and range. Do we have any questions at all before I talk about domain and range? No? Okay. So domain is all the possible x values. Range is all the possible y values. So what I want you guys to picture is kind of moving from left to right for the domain, because left to right gives you all the x values. So take a look at the arrows, take a look at what you would have plotted. As I move from left to right, what x values will get hit by this graph? Okay, I heard someone say all of them. All of them will. So every x value will eventually get covered. So that means your domain is all reals. There's no gaps in the graph at all. Every x value will eventually end up getting covered. Every once in a while, you might see a little gap where nothing is plotted at all, and then your domain wouldn't be all reals, because you have to make sure you account for that gap. Okay, and then the range. Y values go up and down. It's the same sort of thing. Go up and down the graph and see if there are any gaps or if it's all covered. So what do you think for range? Range is also all reals. Good. Every single y value eventually gets covered. There are no jumps, there are no gaps or anything weird happening here at all. Okay, so this would be all reals. Okay, so that's your piecewise function. A little bit crazy. Any questions on it? Yes?
Can you explain the domain and range a little bit more? Like, how do you know that everything will be covered?
So it all is based on really where the arrows are going. So this arrow, it goes down and to the left. So because it keeps going to the left, it's going to cover every single x value, even the ones that you can't see. Same thing with how this arrow goes to the right, because this one goes up and to the right. And then everything that you can see kind of in the middle here, every x value gets hit. Like this one leaves off, but then this one picks it back up. And this one leaves off, and this one picks it back up, kind of right where the last one left off. And same thing with the y values. Going up and down, every y value gets covered. Okay, number 2 is going to feel like a huge relief. Question?
So like for the numbers you chose, then you chose any number you wanted?
Kind of. You can only choose numbers that fall within these intervals. So like for the green one, it had to be something that was less than or equal to -2. So I couldn't have chosen 4, for instance, because 4 is not less than or equal to -2. So you can choose anything you want as long as it's in the interval. So for this one, you have to use the endpoint. You have to use the -2 for sure, but then you could pick anything else. So it didn't have to be -3. It could have been -4 or -5, as long as it's in this interval. And then the one in the middle, since it's a segment like this, you have to use both of those endpoints. And the last one, you use this endpoint and then one other point that falls in this interval. So it had to be bigger than 0, whichever else you chose. Other questions on number 1? Okay, so like I said, number 2 is going to feel much easier compared to number 1. This one, for absolute value, you're just setting up a table. And so just start with little x, y. So you're just going to run from -2 up to +2. So just 5 points. You'll take those 5 x values, plug them in, and then get y values and plot those points. Okay, so when you plug in the -2, it's all going into this expression right here. So absolute value, -2 + 1, and then a +2 on the outside. So simplify it up. Be super careful about the absolute value. Make sure you're actually taking the absolute value when it's there. So on the inside, you have -2 + 1, which is -1. Absolute value of that is +1, and then +2 would be 3. And then do the -1. So -1 + 1 is 0. Absolute value is still 0. And then +2 would be 2. Plug in the 0 for x. 0 + 1 is 1. Absolute value is still 1. +2 would be 3. Plug in the 1 for this one. 1 + 1 is 2. Absolute value is still 2. +2 is 4. And last one is the 2. So inside the absolute value, 2 + 1 is 3. Absolute value is still 3. +2 is 5. So these are all ordered pairs. So for each ordered pair, this is the x coordinate, this is the y coordinate. So go ahead and plot those 5 ordered pairs. Okay, so it kind of looks like a check mark right now. One thing I will tell you, these absolute value graphs, they're always a V-shaped graph. So it might get shifted, like it might move up, down, left, right, might even get flipped upside down, but it's always gonna have that kind of pointed V shape. So it plots like this, keeps going up to the right, and then we know what the shape is gonna look like, so you can kind of continue it on to the left. So you could keep, if you wanted to plug in -3, -4, -5, you would see that it would take on the rest of this shape here. Okay, so that's the graph itself. Any questions on that? These ones are much easier than the piecewise functions are. All right, let's talk domain and range. So domain, remember x values go left and right. So kind of trace your graph left and right. And what x values do you think are getting covered with this graph? All reals. Yep, the arrow goes to the left, the arrow goes to the right. So domain is all reals. Range is all about the y values, and y values go up and down. So go up and down this graph. What y values are getting hit by this graph? Anything greater than 2. Good. And we're actually going to throw in, bless you, we're going to throw in a greater than or equal to, because the 2 itself does get hit. But yeah, 2, we call that the minimum value. It's the lowest possible value that the graph will ever hit. Nothing below here gets hit at all. Okay, questions?